So in this case here, it says, is it possible to connect the points with the coordinates -1, 4, 5, 22, -8, -17 with a single straight line? You must show you're working. Now if we sort of draw this, right, it's like a sketch, a single straight line, we'd see the points -1, 4, 5, 22, and -8, -17. It doesn't matter about it, but points being in the right place, right? That's not the issue here. We're just doing a sketch to show that if they were in a straight line, this is sort of what it would look like. But if you think about it, if they're in a straight line, then the gradient joining the points would be the same, as in the gradient joining these 2 points has got to be the same as the gradient joining these 2 points, if that makes sense. The question is saying, is it possible to connect the points with these coordinates? Well, if we can see that the gradient here is the same as the gradient here, then we've shown that they're in a straight line. Okay. If the gradients were different, what would happen is you'd have a slope going from this point to this point, and then the slope going to the other point would be different. It might be going that way or this way, so it wouldn't be a straight line. But if they're the same slope, joining point to point, then we could show that they've got the same gradient, then they lie in the same straight line. So what we'll do, we'll look at the gradient joining these 2 points, and if we want to call them, say, A, B, and C, that might help. So if I work at the gradient of AB, okay, that would be y2 minus y1 over x2 minus x1. So that would be 22. Take away 4 over 5. Take away then this one, which is -1. So this turns out to be 18. Divide by, that would be 6 on the bottom, so the gradient turns out to be 3. And if we do the same then on the next one, gradient BC, again it's y2 minus y1, isn't it? Over x2 minus x1. So it'll be -17, take away 22, all over -8, and then -5. So if I work that out on the top, I get -39. If I work that on the bottom, I get -13. And that works out to be 3. Now, because they've got the same gradients, okay, then they've got to be on a single straight line, okay? Because as I said, going from A to B has that gradient, and then you keep going from B then to C. If it's got the same gradient, it's got the same slope, okay? So same gradient implies points are on same straight line.